See, hypothesis testing, it's a kind of statistical method. The main use of this one to test assumptions when we build any machine learnings or models and all, and make sure that we do have we need to do so many assumptions. Okay, that particular assumptions has been satisfied or not, that we need to be test with the help of hypothesis testing. Okay, test assumptions about a population, so that we can do with help of hypothesis testing. Let me take it in a one small example. Okay, and so I would like to claim something like that. The average income of my customers is, okay, so here my assumption is what? For example, my assumption is the average income, okay, of my friends or else customers, whatever it is, okay, and of my customers is 60,000 rupees. Okay. See, so this is my assumption. So with help of this hypothesis testing, what we can do, okay, we can check whether this particular assumption or whether if this particular claim is it true or not. That we can test whether this particular assumption is it true or false. If it is true, then your friends or your customers, the average income is 60,000. Okay, if it is your assumption is failed, and then we can say that your customers are not getting 60, or it might be more or it might be less based upon the sample data. See, so you don't have a population, you don't have entire population, right? You have only some set of you have only some sample data. With help of this particular sample data, okay, here we have a population. So with help of this particular sample data, we can test your assumption about your population. Is it clear? So how do you test? How do you hypothesis? How you can do this particular thing? See, for this particular one, we do have various steps. The first step is steps for hypothesis testing. The first step number one is null hypothesis. We have to define the null hypothesis. Null hypothesis, generally we can represent it with H0. So which the meaning of it, no effect. Simply we can say there is no effect, or else no difference. No difference. Okay. And this is, we have to state, step number one is state the null and alternate hypothesis. Null and alternate hypothesis. Okay. And here, second, the step number one, we need to state the null and alternate hypothesis. Under that one, null hypothesis is we can represent it with H0, which means that there is no different your sample and population. Okay. And alternate hypothesis is stating that, okay, alternate hypothesis is stating that we can represent it with H1 or else HA. So if your alternate hypothesis is true, which means that an effect, there is an effect or a difference in with your sample and population. Second step is, this is step number one. Step number two is we have to choose the significance level. Choose the significance level. This is important term, significance level. Okay, significance level. So generally we can represent it with alpha. So usually we can take it like 0.05 is your your significance value. Depends upon the domain. So this significance level, it might be changed. It's a 5 percentage. Okay. If your significant level is less than or greater than, based upon this particular significance level only, okay, we can able to test whether your hypothesis is fail or okay. And as step number four is step number three is we need to collect the data. And you have a significance level, you already state the null and alternate hypothesis. After that one, you should have a data. So collected the data and performing the test. So performing the test. So while you're performing the test, we are going to be calculating the p value. Okay. So while you're performing the test, we have to go for calculated the p value. So in the fourth step, and we have to make the decision. We have to make the decision based upon your p value and alpha value. Okay. If in case here you are calculated the p value, right? If in case your p value is less than alpha, alpha is your significance level. Your probability value or your p value which is less than the, okay, if it's less than the alpha, then we have to go with reject the reject H0. Reject the H0 means what? You're going to be choosing the alternate hypothesis, right? There is a difference. So whether null hypothesis or alternate hypothesis, from these two, you can able to accept only one. Okay. If in case, your p-value, it might be greater than or equal to alpha, then this particular situation, we can say failed, fail to reject. Fail to reject means what? Accepting the null hypothesis. Is it clear? Fail to reject the H0. Okay, these are the four terms or four steps we need to be remembered. So first step is what? So if you want to performing the hypothesis testing, and we need to state the null and alternate hypothesis. Null hypothesis is stating that your sample and population, there is no difference. Alternate hypothesis is stating that population and sample, there is a difference. So which means that both are not same. Okay. And so after that one, based upon the domain expertise and alpha will be decided. Usually we are considering the 0.05. So this is not our task. This will be domain expert will give you this particular value. Okay. And so this is the thing will be done by yourself. Statistical engineer will do that. Statistical engineer will decide the will defining the null hypothesis and alternate hypothesis. And this one also will be stated by the, or this one is also calculated by the statistician only. Okay. And based upon this particular p value and this particular alpha value, we are going to be fail or we can reject the this particular null and alternate hypothesis. The only thing is that we have to go for calculating the p value based upon the test you choose. Okay. So some situation we have to go with use the Z test. In some scenarios, we can use the T test. In some scenarios, we can use the ANOVA test. And in some scenarios, we can use the chi-square test. Okay. Different kind of statistical tests are there to test your to make the decisions. Okay. Based upon the problem and based upon the data. Okay. So we'll discuss all these particular tests and all. But before that, in some scenarios, you might be failed, right? Actually, it's a we need to reject the null hypothesis. But some scenarios, your test will performing the bad result. I mean, your test is not performing well. Because of that one, you might be get some kind of errors, right? So based upon this all kind of stuff, there are two types of errors. Okay. What are the types of errors? There is two types of errors. The first one is type 1 error. Okay. So second one is type 2 error. Type 1 error indicating that actually rejecting rejecting true null hypothesis. Okay. Rejecting true null hypothesis. Actually, we have to accept the we have to accept the null hypothesis, but we are rejecting that one. Okay. So that kind of scenario, we can say that say type 1 error. So in generally, we can call it as the false positive. Okay, I can defining that matrix over here. Okay, and false, true negative, true positive. Okay, true negative and true positive. False positive and false negative. Okay, positive and negative. And your predictions. True negative and a true positive, or it's there is no error. But these terms are having the errors, false positive and false negative. Okay. If in case if it is a false positive, okay, if it is a false positive, it comes under the type 1 error. If it is a false negative, which comes under the type 2 error. Okay, failing to rejecting the false null hypothesis. Rejecting, failing, failing to reject the null hypothesis. Okay. So this kind of errors, we can call it as the type 1 error and type 2 error. So there I already mentioned that where we do have various statistical tests are there. And so t-test and z-test and chi-square test and ANOVA test. Let's talk about, t-test. So what exactly the t-test? See, the t-test, when we can use it, when you want to compare the means, you have the population, we have the sample. Okay, for the sample also we might have the mean, and for the population also we have the mean for it, right? Okay, you want to compare the means of sample and population, or else any two groups, then we can use the okay t-test. Okay, so coming to the jet test, and make sure that when we have a sample data, if it is less than the 30 samples, then that situation we can use the t-test. If you want to compare the means, but your sample data is less than the 30 samples or 30 data points. If in case if you have to compare the means, but your sample data, which it might be okay more than the 30, that means large samples. When we have large samples data, so that scenario, if you want to compare your population mean and sample mean, then we can choose the jet test. And your if you want to compare the means of your population and the sample data, but your sample size is less than the 30, that scenario we can choose the t-test. Okay. And we have one more test, which is chi-square test. So chi-square test, it could help you to test the relationship between the categorical variables. So here we have a numbers data. Make sure that your population and your sample or the number kind of data. That scenario we can use the t-test and z-test. But in some scenarios, you might have the categorical data, right? So how you can test actually? To test the test relationship between categorical variables. Categorical variables. Okay. Last but not least, ANOVA test. So to compare the multiple groups, so here we have multiple groups are there. Okay. So if you want to compare the means of this multiple groups, then we can choose the ANOVA test. If you want to compare only two groups, then we can use t-test and z-test. And but if we have the more than the two group, then we can go with ANOVA test. If we have the categorical kind of stuff, we can choose the chi-square test. Okay. Compare means across multiple groups. Clear? Excuse me. Okay, let's do this particular tests and all. Okay, so here also we have one sample t-test, two sample t-test, different kind of testings are there, and try to check with this all kind of tests and all. Okay, I'm just introduce only few things over here, and for sake of understanding, I would like to take a small example. Go to your terminal and activate your environment. Script activate. Okay. Okay. So fine. Hmm. Yeah. Let's do the t-test. Like that we can do that actually. You will get the code and all from internet, but I'm just telling to you. Okay, so we do have various tests are there. It's not possible to explain all the things, but you can try to explore it. Okay, import pandas as a pd, and we need to go with scipy. So guys, you don't think too much about this all things. I'm just giving you a different things are there. We need to know actually this whole stuff. Okay, there we do have one sample test and two sample test. For one sample test from the t-test, we can use the t-test underscore one sam. So and here we do have a data, right? So I have a data here, and that my dictionary is income, and my question is what my friend's income is or my customer's income is its average is 60K, right? Okay, so that I have some sample data. If it is less samples, it is below the 30, then I can choose the t-test 64,000, 58,000, okay, and 72,000, 48,000, 52,000, 60,000, 54,000, 62,000, 58,000. Okay, this is my data over here. Now what I can do, I would like to convert into data frame. So pd dot data frame. I'm taking this particular data here. Now I would like to apply the t-test. So when we need to go with the calculated the p-value, right? T-test and p-value. So this particular function, it could be returns the your t-value as well as your p-value. Okay. So for storing that one, we are I just defining that two variables here to test one sample, and here I have only one sample data is there. So df dot, here I have income. Okay, and so here my input is no, my average assumption is it's a 60,000, right? So that I'm just giving mean of my population data is 60,000. Okay. So now if I return this one, you will get the p value and t value. Let's print the p value. If it is the below the 0.5, oh shit. If it is the below the 0.5, okay. Is it zero? Is it greater than 0.5 or less than the 0.5? 0.05. It's not 0.5. I can say it's a 5 percentage, right? 0.05. If it is less than the 0.05, then what is the thing I explained you guys? Need to be reject or accept the null hypothesis. So if it is the less than the 0.05, then we need to reject the null hypothesis. Otherwise, if it is greater than or equal to 0.05, then fail to reject. Fail to reject means what? Accepting the null hypothesis, right? Okay, fail to reject null hypothesis. Now, your p-value, whether it is greater than 0.05 or less than the 0.05, which is greater than the which is greater than the 0.05. Am I right or not? This 0.35, which is more than the 0.05 or not? Say yes or no.
Yes, it is greater.
It is greater than 0.05, right? So that we fail to reject the null hypothesis. What generally null hypothesis is stating? No difference, no effect, right? That means your population and I mean your average salary is, here I'm stating that null hypothesis, average salary is 60K. This is not my null hypothesis. H1 is average salary is not 60K. Okay. Now tell me, based upon this particular logic, fail to reject the null hypothesis, right? That means you're accepting the null hypothesis. So your salary is, I mean, your average, your customer average salary is it 60K or not? Yes, it's a 60K. Okay. So this is passed. Accepted. Okay. Is it clear? And I'm taking that new data, but this time I'm taking different values and very huge difference I'm considering. See, one guy is getting 5 lakhs, one guy is getting 7 lakhs, and one guy is getting 6 lakhs, and one guy is getting 4 lakhs. See, same thing, we can try to run it. Is it less than the 0.05 or greater than the 0.05? It's the less than the 0.05. If it is less than the 0.05, okay, we need to reject the null hypothesis. If you reject the null hypothesis, then what happens? The average salary is not 60K. Okay, got it? See, I'm just changing the data points 5 lakhs and 7 lakhs in some scenarios. So here, I got the p-value is, it's a less than the 0.05. So we can reject the null hypothesis. If you reject the null hypothesis, that means you're accepting the alternate hypothesis only. So average salary is not 60K. Is it clear or not? Hello. Hello. What happened, guys? You're not responding anything. I don't know why.
Yeah, yeah.
Did you get this logic or not? Why we are rejecting, why we are accepting? If you're not aware of these things, it could be very tough in future classes. Okay, rejecting the null hypothesis means accepting the alternate hypothesis. Fail to reject the alternate null hypothesis means accepting the null hypothesis. Meaning of those things. Directly we can write it, but This is the technical terms actually. Okay. Is it clear? So not accepting the null hypothesis means accepting the alternate hypothesis. Accepting the alternate hypothesis means not accepting the sorry, accepting the null hypothesis means accepting the null hypothesis means not accepting the alternate hypothesis, right or not? Okay. So just note this points actually. It's very important, you know. Um, so when to reject, when to accept null hypothesis based upon your p-value only. Okay, if your p-value is less than the significance or it might be greater than the significance level. Based upon that one, we can reject or we can not reject. Okay. So this is how we can test with various things actually. Correlation means you can say that, you know, how two variables are you know, associated and all. We can find that relation. Positive relation, positive correlation indicating that one variable increases, another one is also increases. Negative correlation means one is increasing, second one is decreasing. No relationship means there is no relationship between the, no correlation means there is no difference between the, or there is no relationship between the variables. That is correlation kind of stuff. Okay. And hmm. So guys, you know, tomorrow I would like to start the regression analysis. So by the way, I can give you some example for the simple linear regression and all, and multiple linear regression, and so how we can check the your model performance based upon the R square and P square, P value and residual plots and all. After that one, we can check with the chi-square test for independence level and all with some examples, and even with the ANOVA test and multi-collinearity. Okay. So we'll try to cover tomorrow with you know, we'll try to finish um, this particular concept by tomorrow session. Okay. Mostly tomorrow, it's a kind of machine learning part introduction only. Okay. Yep. Thanks, guys. Bye. Take care.